Hello everyone, let's discuss QueryGPT, a solution made by Uber to create SQL queries from natural language using generative AI technology. We'll discuss what were the initial thoughts of making QueryGPT, what were the initial solutions, what were their drawbacks, how they improved the solution, what was the evaluation strategy, what were some key learnings that they brought from this particular solution. So let's begin. Now SQL is something that every industry uses a lot. So at Uber as well, they are actually using SQL extensively. Helps them to manipulate terabytes of data every day. Every now and then. So one thing about SQL is mainly used to fetch data from data sets. You can create joins between data sets and apply some filters, do group bys, partitions, etc. and basically get your required analytics output or any of the output that you desire. For making an SQL query, only understanding SQL syntax and understanding how to write SQL is not necessary. That's not the only criteria you need to know. You also need to know what are the internal databases, what are the internal data tables that are something you need to use to actually fetch some required data of your choice, because there could be some areas where you don't know even data exists or not. So having thousands of data sets, that's also crucial thing to know. Given a query gpt like a tool which can do everything automatically is a great boost to productivity, obviously. So query gpt mainly uses three things, which is llm, vector databases, and a similarity search algorithm. So let's move to the motivation of why it is needed. So what happens while an analyst is actually creating an SQL query? So let's say he or she wants to know some kind of data from some table, and nothing is known about the tables, etc. So first thing is trying to find the relevant data sets by either typing in, querying, word matches, etc. from the entire data dictionary, data set, table dictionaries, etc. If person is not able to find the exact data set, he or she has to connect to right data owners and fetch that particular data set. Let's say the data set is found, then the query has to be generated, written down, and finally we fetch the data. If data looks exactly how we thought of actually getting it, then it's a yes. Otherwise we have to repeat the entire process again. So obviously this is a very tedious task. um, at Uber as well, every day millions of queries are being every month millions of queries are being hit, and it becomes crucial part to actually uh, make something which helps automate things, exactly how query gpt aims at doing. So according to the analysis, it normally takes 10 minutes to author the entire SQL query, so which query gpt aims at bringing down to just 3 minutes. So again, it's significant boost to productivity. Talking about the architecture, uh, this particular idea generated in hackathon, and they have right now claiming to make more than 20 iterations to the algorithm, but the initial algorithm looked something like this, wherein they will be taking in one input, which is a user query, a natural language input, let's say English. They will be fetching some of the relevant SQL samples and relevant SQL tables with their schemas from the entire corpus of their data set, and they will be using all this information to fetch the relevant ones and add it to their query, and kind of making a smaller query, a smaller, you can say, filtered query, and passing it to the LLM. So this is basically simple RAG architecture, wherein you are fetching in some relevant information, adding it to the prompt, and giving it to the LLM. LLM looks at the entire information at once and returns the answer. So what they return is the SQL query along with the explanation that how LLM went to this particular query generation, right? If you talk about the steps, obviously the steps in a simple RAG would be taking into the input, vectorizing it, finding the similar SQL, in this case SQL tables, schemas, etc., and fetching certain number of these relevant tables and schemas, and using this to actually generate the final answer. So for their simple solution, they use just 7 tier 1 tables and 20 SQL queries in their entire data set or data corpus, you can say, which they try to showcase that yes, this kind of a solution can actually work, and they showcase that yes, automated SQL generation can happen. Uh, this is just a dummy example of how a particular schema could look like for a particular data set, and there could be thousands of such datasets in Uber's corpus. You can pass in any additional information to the prompt to actually improve your responses. So this is simple stuff. This is a sample generated answer from the particular LLM they used, wherein the question was find the number of trips completed yesterday in Seattle. So this is what the LLM generated as an output, and this was explanation part how it actually generated this particular solution, right? So given this particular simple solution, when they tried to scale this to, let's say, a larger audience, this didn't work out pretty good. The accuracy etc was not up to the mark. So they tried to think of ways how they can actually improve this particular solution. So obviously the first thing was to actually make a better RAG architecture instead of a simple one, right? What they thought of doing is adding in agents to solve different pieces in a different way, rather than giving just a simple single shot solution from the LLM. We are trying to now break down the problem into some smaller problems, wherein they will make use of the LLM agent at each step, the same LLM agent at each step, and that LLM agent will try to solve this particular problem first, and the output from this particular problem will be given as a next step input. So the idea is to break down the problem further, again using LLM only. No development or no new model was created from their end. So the first thing they thought of is how about knowing the user's intent at first place. This will help them to actually skimmer down the total number of relevant tables or relevant schemas that are actually needed to write the correct SQL query, right? So the first one is identifying user's intent. Okay. The second one is which was a major problem in their naive solution was some tables could have very large amount of columns, you can say, and these columns, if given directly to the as a prompt to LLM, could lead to large number of tokens which an LLM could not suffice in one query. So this was another problem they were facing. So they solved this in using another agent. We'll discuss that. So this is the latest in production solution that they have made, wherein we'll go through everything step by step. So the input of natural language remains the same, and the final output, which is SQL query and explanation, remains the same, right? They have broken down the intermediate steps in simpler ways, right? First of all, what they have done is they are making different workspaces to actually dissect different data sets into different workspaces, making smaller chunks of different, or you can say groupings of different data sets and schemas, and they call it as system workspaces or custom workspaces. They have given some examples also which we'll discuss. The first problem boils down to finding the intent of the user, to actually which workspaces he or she is actually referring to. So this is the first task of the LLM: find the right workspaces and individual you can say blocks, and each block has individual tables and schemas associated, so that we are fetching the right, or we are targeting the right data sets at the first step. This is the first thing they are trying to solve with LLM. So let's say we fetch a set number of you can say tables. Now finding the right amount of tables and asking the user itself is the task of table agent, wherein user will be given that yes, these are some set of tables that I have fetched. Tell me if this is right or wrong. If not, add in your own data set. You can search the data set and then I will go ahead. Right now, as we mentioned earlier, some tables can have huge number of columns, so actually not all of them are needed. So one more agent, which is column pruning agent, is also added to actually prune only the needed columns into the further query, not requiring all the columns, obviously to reduce the total number of tokens in a particular query. Finally, doing all these steps, our entire query is made up, which contains again the input prompt, along with the relevant SQL tables, along with the relevant SQL schemas, SQL queries, etc. And then this is actually sent to the LLM after careful. So after getting this particular input to the LLM analyzes it and gives back the response. So let's break down everything step by step and look at it. So first thing is workspaces. uh, as I mentioned that these workspaces can help the LLM focus on the right or relevant data sets which it should look at to actually answer this particular input prompt. So these are actually made manually or dissected into smaller chunks manually. Whenever any person, let's say, doesn't find his or her workspace or the right workspace or the right tables, a custom workspace can be made, stating that none of the existing workspaces fit the requirement, and this will be added to the collection of workspaces. So talking about intent agent, as we discussed that this is the first agent that is going to be triggered, and the role of this would be to map the user's intent question to one or more business domain workspaces and fetch all the SQL samples and tables which are tagged to that particular workspace. Now this drastically reduces the total amount of search that was done to actually find the right tables. So this is the first thing that was. Okay, so let's discuss about table agent now. As we discussed, intent agent role was to actually pick up the right intent workspaces, and when we pick up any one or more workspaces, the mapped SQL tables and SQL samples obviously come into picture. Table agent's role would be to filter down on those tables as well and get the right set of tables, and actually according to them they took a feedback from users itself that QueryGPT is not finding the right tables to query. So people should get an option to actually acknowledge that if the next steps the next steps for which the query is going to generate the output, oh sorry, LLM is going to generate the output, uh, is query GPT is using the right set of tables or not. So this is how they showcase the set of tables they are going to use for any particular query, and if a person clicks on looks good, uh, this gives a go ahead to the query GPT that yes, these tables are right, and it moves forward. Otherwise they can omit any of the tables and add in their own required tables. So this was the second agent they used. Let's talk about the third agent they used was column prune agent. As I mentioned earlier that some tables can have huge schemas which can actually overflow the amount of token limits in any given LLM query. So the role of this agent is to prune unnecessary columns and only flow in those columns which are actually needed in the next steps of the pipeline. So this again solves this particular problem only, and aims to make the entire query size much smaller than the original one. So this is a sample output from intermediate set that yes, for any particular query, some set of columns were actually needed and some were very obviously not required, which were removed by this particular agent. So let's discuss given these agents, and finally getting this final prompt and giving it to LLM, and LLM creating a response in return, how do we evaluate if we are in the right step or if we are actually improving on previous solutions or not? So this is how their evaluation strategy looks like. They actually maintained a standardized evaluation procedure wherein they are going to look at different questions and trying to make the ground truth by themselves, looking at different types of questions, including the questions which include many different types of data sets, different types of workspaces, etc. um, Obviously not all types of data sets or workspaces can be included, so the best that they could do is find out the most relevant ones and actually finding the right intent for each of that particular question, right schemas, and actually making the right golden SQL query. Now this will serve as the ground truth for which they will be comparing all the outputs from each of the iterations, right? So they evaluated two kind of product flows, you can say. One is the vanilla one and one is the decoupled one. So vanilla one aims at checking each and every step, which is first is the intent step, then the second is the finding the right data sets, and obviously the last one is a SQL step. In this vanilla step, uh, nothing is decoupled. You can say if intent step makes a mistake, that mistake flows ahead to datasets, and if datasets makes a mistake, that flows ahead to the SQL query. But the second flow they made was decoupled step, wherein they will be giving the right intent and right datasets, and they check if the query GPT is able to make correct SQL output given the right intent and datasets or not. They actually made certain different types of responses which they can qualitatively use. Let's say how much table overlap is basically happening between the ground truth and the response given by LLM. Is the intent actually right or wrong? How much overlap in the intent? Was the run successful or not given a query response? Will the query even run or not? Will it generate any output or not? um, if not, then what could be the wrong thing in the particular generated SQL query? All these things they actually evaluated, and obviously they tracked everything through a logging system, and there is a particular uh, metric also they tracked to actually see. These are some set of metrics that they actually calculated, like some examples are percent of questions which actually match the context, or average number of data set overlap score, etc. This helps them to actually evaluate if any further improvement in the solution was actually happening or not. So this is a set of evaluation strategies they developed. So giving one example, let's say the SQL query generated was very similar to the right golden set SQL query. Let's say it had a 85% match, but if it doesn't run, that is actually a waste SQL query, because in code single word can make all the change, make all the difference. So that's why each and every evaluation step is actually important. Not only a single metric is the most important thing. Talking about some of the limitations, so obviously we know that LLMs are not deterministic even in a forward pass. So they actually took into consideration any improvement if there was more than, let's say, a 5% run to run changes in most of the metrics. And obviously they knew that not all the data sets and workspaces can be included in their golden ground truth data set. So all these things were actually looked into and considered as their limitations only. Few learnings that they mentioned that they had were, obviously everything was done by LLM, so they knew beforehand that LLMs are very good classifiers. At each and every step they proved it. And I also looked at breaking down the problem into simpler chunks and assigning each agent to different problem significantly increased their accuracy. because each agent was very good at its own job. Rather than assigning all the tasks to a single LLM as a generalized task, this actually proved to be very good for them. Obviously, LLM also was giving hallucinations, wherein it was giving outputs for tables which didn't exist at all or columns which didn't exist. So they actually tried to improve this or reduce these hallucinations by making a validation agent also, but it was not concluded yet. Um, they also saw that all user prompts are not always good. So they actually used prompt enhancer for every given, uh, you can say, prompt by any user, which actually improved the quality of the input to LLM, uh, proved better in terms of responses. Um, So, talking about how this actually proved to be a success or not, so they mentioned that on an average they are getting 300 daily active users, out of which 78% are claiming that yes, this particular tool helps them to reduce the amount of time they are writing to writing the SQL queries from scratch. So yeah, this was about the entire solution. Uh, just summarizing at the end, let's look at the final architecture once again. So they broke down the problem into simpler chunks, wherein they are first identifying the intent of the user given the natural language. The intent is actually identified from a set of already existing workspaces that Uber developed, and each workspace is mapped to individual SQL tables, schemas, etc. Getting this response, the next agent filters down to the even better tables which are needed, SQL schemas, SQL queries and tables which are actually needed to solve this particular natural language input. uh, Given these particular data table inputs, manually user selects if this is right or wrong. Upon that selection, the columns are pruned which are not necessary are pruned out, and a smaller set of columns are actually remaining at the final step. And the final output from this particular column prune agent and along with this natural language input prompt are combined together, given to an LLM, and LLM creates a SQL query with explanation. So yeah, this is about the entire solution flow the Uber made. Let me know if you guys have any advancements or any improvements that you can think of for this particular solution. I hope you like the discussion today. Thank you.